This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. Does the following sequence converge or diverge? If it converges, what does it converge to? All you have to do is just take the limit as the numbers in the sequence go on forever and find out what those numbers are being limited to, right? Because the sequence is just a list of numbers that goes on forever, and you want to know, as the numbers go on forever, if the numbers here are going to be limited to like the same value, like 1, 1, 1, 1, 1, 1. If not, then it diverges. So if you get a finite number, then that is what your sequence is going to be limited to. And if you get infinity, then your sequence just diverges. So if we go ahead and plug in infinity, we'll get infinity times and then 2 over just infinity, that goes to 0 because one whole divided into infinitely small pieces becomes infinitely smaller, so small, it goes to 0. And then we just have 1 minus 0, which is just 1, and ln of 1 is just 0, so we really have infinity times 0, and that's indeterminate. So then remember that we can do L'Hopital's rule, but we have to get it as a fraction first in order to use L'Hopital's rule. So what stands out to me is this: I can always rewrite this as 1 over n in the denominator, because remember, to get rid of this, all you have to do is multiply top and bottom by n. So then it cancels out this n, and you're just left exactly what we had in the first place. So anytime you just have a variable next to something else, you can always just divide by the opposite of that variable, 1 over that variable. Then now if we plug in infinity, 1 whole divided to infinitely small pieces gets infinitely smaller, so small, it goes to 0. And then if we plug infinity here, same thing, even though it's 2 wholes, it doesn't matter, goes to 0. 1 minus 0 is 1, ln of 1 is 0. So essentially we have 0 over 0, and now we can use L'Hopital's. L'Hopital's rules just says take the derivative of the top function and take the derivative of the bottom function. The derivative of ln of anything is always just 1 over whatever the stuff's inside. But because we're taking the derivative, we have chain rule, and we have to multiply it by the derivative of the stuff on the inside. So that's just going to be this. So the derivative of 1 is just 0, of a constant is 0, and then the derivative of this, well, we can rewrite this as 2 over 5 n to the negative 1. And then we can bring out this negative to the front. So then we have minus 1, so it becomes n minus 2. And so this is just negative 2 over fifths, and then n squared, because the minus 2 says, hey, bring it down to the bottom. And then the derivative of this, well, you can just rewrite that as minus 1, negative n, and then minus 1 goes negative 2, negative 1 over n squared. Now that you did L'Hopital's rule, simplify it again so you kind of get it in the form that you had it in the beginning. So what I noticed is that I want to get rid of this fraction in the denominator, so I can just multiply by n squared. That's going to cancel out this, but whatever I do to the bottom, I have to do to the top. So multiply this by n squared, so it's going to cancel out these. And recall that there's no such thing as a distributive property for multiplication. So just because you had n squared here doesn't mean you multiply to each. But when you have things that are being multiplied together, they're just being multiplied together. So you only have to do it just once. So now we have this constant that we can bring out to the front. This here just becomes a negative, and then if we try it again, if we put an infinity here, 1 whole divided into infinitely small pieces becomes infinitely smaller, so small, it's going to go to 0. So we have negative 1 over 1 minus 0, which is just negative 1 over 1, which is just negative 1. But this is being multiplied by negative 2 fifths, so our limit is 2 over 5. Because the limit of the sequence as the numbers in the sequence go on forever is limited to 2 over 5, that means that you'll just see 2 over 5, 2 over 5, 2 over 5, literally forever as the numbers go to infinity. So we say that the sequence converges to 2 over 5. And that is our conclusion. I'll see you in the next video.